In this lecture, we're going to talk about the two most basic kinds of particles in chemistry, atoms and molecules. Atoms are the smallest particles of an element that can exist and still have the properties of the element. Atoms are not the smallest particles. There are many particles that are way smaller than atoms. However, those particles do not have the properties of the element. Again, atoms are the smallest particles that can exist and still have the properties of the element. Needless to say, atoms are very small. If you have 254 million atoms lined up together, it is about 1 inch only. An atom does not usually stay by itself. What happens most of the time is that two or more atoms will combine together to form a new unit. This kind of unit is called a molecule. A molecule behaves in many ways as a single distinct particle. Its behavior is different from those atoms that are in it. If there are two atoms in the molecule is classified as a diatomic molecule. If there are three, it's called a triatomic molecule. And we have tetra, pentatomic, etc. If there is only one kind of atoms in the molecule, that molecule is called homoatomic molecule. Substance containing homoatomic molecules must be an element, or we can say an element consists of only one kind of atoms. Here are some examples of homoatomic molecules. Oh, some of you may ask, what are all of this? These are called chemical formulas. Chemical formulas are formulas that chemists use to represent a substance. Here, let's look at H2 as example. Okay, H2 means this substance has hydrogen atoms in the molecule, and in each molecule there are two hydrogen atoms. The subscript 2 tells you how many hydrogen are there. The capital letter H tells you in the molecule you have hydrogen atom. Okay, so look at the last one, S8, substance sulfur. It tells you sulfur has sulfur atoms in its molecule, and there are 8 sulfur atoms in one molecule. Okay. Again, in the chemical formula, you use elemental symbols to tell other people what atoms are there in the formula, and you use subscripts to tell you how many of that atom are in there. This picture gives us 3 examples of homoatomic molecules. It shows us how the atoms in each case are connected within the molecule. Once we understand the concept of homoatomic molecule, we will naturally understand the heteroatomic molecule. A heteroatomic molecule is a molecule in which there are 2 or more kinds of atoms. A substance containing heteroatomic molecules must be a compound. Or we can say a compound consists of more than one kind of atoms. Here are examples of heteroatomic molecules. Look at the first one. Many of us know that there's water. So H2O tells us in the water molecule there are 2 hydrogen atoms and 1 oxygen. atom. We can see that oxygen has no subscript. So in the formula, if there isn't a subscript for an atom, then that tells you there's only one of that atom in the molecule. Do not ever write the subscript 1 in any formula. For example, CO2, it tells you there's 1 carbon and 2 oxygens in that molecule. Look at the last one, C12H22O11. We may not know what it is, but we can say that, but we do know that the formula tells us there are 12 carbon atoms, 22 hydrogen atoms, and 11 oxygen atoms in that molecule. That sounds like a lot of atoms in a molecule. However, a molecule can have thousands of atoms. Okay, again, picture shows you a few examples of heteroatomic molecules. All right, concept check. Classify xenon tetrafluoride as first diatomic, triatomic, etc. Okay, all right. In xenon tetrafluoride XeF4, there's 1 xenon atom and there are 4 fluorine atoms. Totally, there are 5 atoms in the molecule. So it is a pentaatomic molecule. Number 2, is it homoatomic or heteroatomic? Of course, heteroatomic. There are two different kinds of atoms in it. Is it an element or a compound? Of course, a compound. There are 2 different kinds of atoms in the molecule. That's a compound. An element will have only 1 kind of atoms in its molecule. Oh, this slide talks about chemical formulas. We actually already know most of this. Go through the statements. It basically tells you what I just explained. To write the molecule of a substance, you use the element symbol to tell other people what elements are in there, what atoms are in the molecule, and you use subscripts to tell other people how many of those atoms are there in each molecule. Examples here, let's look at them. H2O, okay, this is the one we just talked about. Hey, we see something new here. In this formula, Ca3 parentheses PO4 parentheses 2. Okay, what is this? Well, sometimes in the formula, there are small groups of atoms inside a bigger formula. These small groups of atoms, they always stay together. In this case, 1 phosphorus and 4 oxygen atoms, they will always combine together to form a small unit. And in this formula, Ca3PO4 there are 2 of the small units in the whole formula. As a result, in each formula, there are 3 calcium atoms, there are 2 phosphorus, and 8 oxygen atoms. In each small unit, in each small PO4 unit, you have 4 oxygen. You have 2 of those units, so 2 times 4, 8 oxygens. In each small unit, there's only 1 phosphorus, and you have 2 of those units, so you have 2 phosphorus atoms. Exercise. For each of the following chemical formulas, determine how many atoms of each element are present. All right, H2SO4, all right, pretty straightforward. 2 hydrogen atoms, 1 sulfur, 4 oxygen atoms. Oh, this one is a little trickier, a little harder than the first one. Iron, there are 2. That's it. Okay, in this formula, there are 3 CO3 units. In each CO3 unit, there is 1 carbon. 3 units will be 3 carbons. In each CO3 unit, there are 3 oxygens. 3 units will have 3 times 3, 9 oxygens. So in this formula, we have 2 iron, 3 carbon, 9 oxygens.